There are large uncertainties on the carryover effect from grass clover to the following crop. This is due to soil type, location in the country, percentage of clover in the system, and amount of fertilizer. Therefore, we're testing the optimal level of nitrogen supply and the source of nitrogen supply, if it should be from legumes or from fertilizer. And we're trying to calculate the best balance, which can be both economically viable and also hit the right requirement for the crop. This will cause both to have a good economy at the farm and reduce chances of losses into the system. In this experiment, we're calculating the nitrogen requirements of maize sown after clover grass. To do so, we have regulated the amount of clover in these experiments in 3 parts of the country, and we look at how proportion of clover impacts the yield of the following maize. For example, here we have 3 levels of clover percentage, namely low, less than 10%, medium, between 20 and 30%, and high, more than 40%. Next year, we will terminate these grassland fields and establish maize, which will be fertilized with several levels of nitrogen. In this way, we can calculate the nitrogen needs of the maize and see how different proportions of pre-crop impact the nitrogen requirement of the maize. In our previous research, we have seen a high variability in yields in maize after clover grass. That can be due to the fact that clover grass is sown with different percentages of clover and fertilized with different amounts of nitrogen, resulting in different carry-on effects of nitrogen to the following crop. As well as creating uncertainty in the nitrogen requirements for the following crop, this also creates the possibility of having over-fertilized systems, which can lead to nitrate leaching. We will use the knowledge generated from these experiments to calculate optimal nitrogen requirements in maize after clover grass, and results will be published in the Landsversöhne.